So we had some of the technologies providers who just joined, and I'm just to get this started, the ball rolling a little bit. I'm going to ask the Kevin, Arun, and Stefan a question, and then I'll open it to questions from the audience. So I'll start off with Kevin. Your EAM system, Katie came from the agricultural area. Could you talk a little bit about what other industries that Infor EAM is applied to?
Sure.
And you only got a couple of minutes.
Can you hear me okay? Yep, good. So we have thousands of customers around the world. We've been having done this since 1986. That was the first line of code that was written out. We have applications everywhere, but I'm not aware of one in Antarctica, but pretty much everywhere else. Last year, we had a partner of ours come and do a presentation on their IoT deployments within airports. The year before that, we had CERN. CERN is in Switzerland. They do Large Hadron Accelerators. Before that, we had Lopez Foods, I believe. Before that, we had City of Des Moines. We've brought customers out every year since about 2013. The application's designed to do a lot of what we talk about here, from the beginning of decision-making of the asset to the actual disposition of it. We call it from lust to dust. And the reason for that is because when you're planning that asset, you're in that phase of trying to understand where it goes and how it works. And then from dust, when you actually dispose of it and go through. And we incorporate a lot of different techniques to be able to understand the condition of that and how to elongate that asset to get the best out of it that you can in the best way possible. Yep.
Very good. Thank you. Thank you. Arun, if I could ask you a similar question. Petasense is known for condition monitoring and of assets, and could you talk a little bit, maybe perhaps the types of assets that that your customers have applied it to?
Yeah, sure. Just a little bit of background about Petasense. We're based in Silicon Valley. We've been in business. We are, I think, the youngest company here. We're a startup that's been in business now for about 3.5 years. I guess that's long in startup land. So we make, this is the product, the Petasense vibration mode. This sticks on like dance machines, and then we also have the software component. In addition to critical facilities, we call Stanford a critical facility. We have a few other verticals we've been working with. The initial focus of the company of Petasense was rotating machines. So a lot of industries use critical rotating machines. We have a lot of customers in the power generation space. And power generation, we monitor traditional combined cycle plants, gas turbines combined with steam turbines. We are also in one of the largest nuclear power plants here in the United States. So nuclear has hundreds, if not thousands, of rotating machines in a nuclear plant. We are now in a gold mine. That's a project that's starting pretty soon. Pharmaceutical, we have 3 of the top 20 Fortune 500 companies that are already using Petasense technology to monitor rotating machines both inside of the manufacturing plant. It's called the GMP area, mixers, homogenizers, and things like that. And also a lot of equipment on the HVAC side, like DANs, like chillers and air handling units and cooling towers and things like that. So rotating machines happen to be one of the largest categories of machines. So if an industry has a critical rotating machine, we can monitor it.
Thank you very much. Could I see that vibration monitor thing? Not very often people bring toys. Oh, it's got a magnet on the bottom?
No, it's actually, it's a steel. You can stick it. You can stick it, stud mount it. Yeah.
Nice.
It's a couple of inches tall. It's wireless.
A toy I could play with. Stefan, IBM, big company. We know a lot of us have read a lot about it. A lot of us are familiar with Maximo, but this predictive maintenance application that I can't quite get the name right. I don't want to, Mahi. Could you talk a little bit maybe what industries or what types of applications that's been applied to?
Yeah, so this is one of our newest.
A little closer and it'll work better.
So this is one of our newest modules we have within Maximo. And so you saw it for General Motors, but we have applied it in oil and gas. We have applied it for aircraft engines. Basically, larger industrial companies have taken up on that.
Okay.
for us, it's sort of like, we always had Maximal. We had it for a very long time. IBM acquired it about 12 years or so ago.
Yeah.
It has always been the leading market share product in that space. Gartner ranks us pretty highly, and so does ARC, which we are very happy about. But the key, I think, really here is to get out of this, okay, I'm scheduling maintenance, I'm doing workflow, which is very important, into how do we get into that IoT space where we want to think about how do we make the assets better. So we think of that as asset optimization, and then how do we make the operations better? GM in the end, they care about how many cars are rolling off the line in every hour, right? So 60 roughly is the number. And I worked for GM for 15 years. I also find it very amazing that that's actually working, and if you, Tony talked about the supply chain. If you think about it, so they make 10 million cars, 3,000 parts a car. So that's 30 billion parts that have to be coming together at some point in time, at the exact right point in time. That's really the big challenge they're having. And so asset management plays a key role in that, because if you don't have the assets ready, you're really out of luck. But coming back to your question, so across the board, it goes across the board, but really MAI is our first step into IoT for manufacturing.
Excellent. Thank you, Stefan.
One of the other ones here in Florida is Tampa Bay Power and Lighting. They're working closely with them too.
Good. I'm open to questions. Go ahead. The man in the red shirt, that certainly sticks out.
Hi, Clark Stunner from Dow Chemical. First of all, I got to really appreciate this presentation from this panel, because I've done a little bit of reliability engineering in the past, so it strikes at home with me, and I've really enjoyed it. So thank you very much for sharing. I do have a question, and I was trying to take notes, so I probably missed this. Are you using your data, your sensor data, to generate, and this is a general question for all of you, to generate your work notification automatically based on certain parameters? And if you are, how did you manage the culture around false positives with your leadership and your staff?
When we start off, in the order that you spoke, Katie, if you'd like to speak to that first.
We're primarily using our data just to drive the PM generation. So, right, because we're not collecting failure data necessarily, we're collecting hours run and distance traveled. So, it has been a little bit difficult to break some people of that, but I'm here, let me just fix it while I'm here, But it just takes patience and reiterating, kind of correcting it and making sure that they review their schedule. These are the PMs that are released, and we try to make the transition simpler by giving them some control. So they still can get an assortment of PMs that they have to do for that week, and then they can still have a little bit of ownership in deciding how they build that schedule.
Can I ask a follow-up question? I'm sorry. I got a lot of interest here on this. So when they go and they work on something, are you collecting data when they find nothing wrong?
Yes.
Okay.
Yes, I mean, we have a checklist, and we want to know if everything checks out and it's good. That's important for us to know as well. I think that helps us build our long-term plan of if we want to adjust those frequency points that things are triggering.
Good.
So yes.
Thanks, Katie. Dan, would you like to add some?
Yeah, sure. Right now, when we get alerts, it's going to a maintenance planner, and he's doing the triage to determine whether or not he needs to issue a work order and who to issue it to. Hopefully, I'm hoping to go down the line where we get certain alarms like critical or signatures that we know who immediately it should go to, that we could generate it automatically and get it done. But at this point, we're not there yet.
Tony.
And in GM, we're just starting in this space. So we're just starting a project to start generating those. So we're dealing with that now. And it's a learning experience.
Maybe I can just add a little bit to how we are enabling that. We calculate health from the sensor data. Each machines of Dan's, we form a baseline over the first 2 weeks. We form a baseline for vibration. We are adding other parameters in the future too, but right now it's vibration and temperature. And using anomaly detection class of machine learning algorithms, we give a score. So that's what they get an alert on. So perfect health is 10, and it starts, going down if there's a lot of deviation. So hopefully we will start getting, as we mature, as the system matures, below 7, you need to automatically generate a work order and things like that. As we get more and more data, and the health score will be a real good indicator for when to generate an automatic work order and things like that.
Rune, if I could ask, is it just first order vibration, or are you able to look at the second, third order harmonics?
Yeah, so that's one of the reasons we designed the sensor all the way through, right? We wanted to give that end-to-end experience. The machine learning algorithms that we deploy, takes into account 30, 40 different features from each of these sensors. And, if it's a motor, vibration is a complex science. It's been studied in mechanical engineering for a while. So you're looking for different things. If you're trying to monitor the health of a bearing, you're looking for different frequencies, and you're looking for changes in that.
Okay.
If you're looking for a gearbox, it has its own defect frequencies. If you're looking for a pump. So based on the type of machinery, we are looking for very specific things in the vibration signature and for changes in that to give a health score.
I think really the important part on that is to figure out how does it fit with the workforce. So if you have a workforce where you have zero capacity, you probably don't want to generate any, right? Because they're basically busy with reactive and they cannot do a single thing more. As you're moving into predictive and preventive, you're seeing them that free up, and so now you can afford more false positives. So I think if I were you and you're getting into that, I would measure that. I would measure basically the utilization of my workforce and adjust my false positive versus the false negatives. And after a while, if you get really good at it, they're going to get mad at you for the false negatives because something breaks and you didn't tell them before.
Good. Go ahead.
Mike Radigan with Leidos. Dan, in your presentation, you highlighted the need to engage IT early in the process. My question is around the cybersecurity concerns, maybe for all your projects, and specifically, where did you see, let's say, IT security being like an enabler, or where were they a barrier that you had to overcome?
Yeah, I have different experiences with them. We have our own IT group within our group. It's land, buildings, real estate, and they're dedicated to providing us with service, and they're also, making sure that we don't do anything that's going to, give anybody access through a back door somewhere. And they're very specific about the types of interfaces and the controls that you can have as far as accessing data, going through networks to get into the facilities. And if by getting them on board early with this one, we understood that when we constructed our Wi-Fi, that we had to make it a dedicated network just for our facility, and not go on the general Wi-Fi in the campus, so that they would allow us to send out to the cloud, because if we didn't, then they would not have, and we would have had to redesign the circuit just separately just to get it out. And the same thing happens too with our solar generating station. We wanted to be able to have a mechanism to go and pull the data from that station into our database and our workstations, and they, I forget the exact way we had to do it, but they had to dictate the protocol how we had to do it. And if we would have done it ahead of time and told them how we were going to do it, probably would have been weeks. But we waited and finally told them what we were going to do, and then going back and forth with them, it took months to finally work a solution out. It's things like that.
All right. Keep you from running a lot. The gentleman right next to you, and then we'll come over here.
Hey, by the way, great question. Thanks for joining us today. Kind of as a follow-up to that question, I understand the importance of bringing in IT in as early as possible. But when you're making these IoT decisions, whether it's on the factory floor or something in the field as far as asset tracking, who are the sort of decision makers that are going to actually kind of pull the trigger on that move?
David, over here next. Go ahead, please.
Yeah, so from IT perspective, we've seen this with several companies, right? There is usually the CIO organization takes the lead. and they bring in different folks. The CIO organization, usually they have solution architects, and what they're starting to do, and we are influencing those discussions right now, they're starting to put together what's like an IoT strategy. What's an IoT architecture that can work? What's the security standards? Then they bring in the information security group, and they approve architectures and things like that. What we have found to be very beneficial is actually being independent of the control system is a benefit. There is an air gap between the IoT network and the control system, so it can't touch anything. The other way we pitch this is, look, it's monitoring only, right? So we just reading data. It doesn't have any wires. It's just sitting on a piece of equipment. So you can sell this in those ways to IT and to information security organizations.
So
Go ahead,
what
Kevin.
we see is a bit different. It depends on the nature of your business. So New York City MTA uses EAM to manage a little over 1 trillion assets. And their deployments and their concerns a little bit different from what you would manage if you were managing a school district, for example, or something even larger, more complex details. So with that in mind, the buyer that we've seen, that we go into, ends up first starting really around the operations for us. So within the wheelhouse of the COO, and trying to understand what their assets are, how they keep them safe, what their original purpose is, what is the meaning, why we have this asset to begin with, and what are we trying to do? What are our risks for it? What are our goals for it? And then from there, you can help build out a use case, a business case, for what ways that you need to understand condition. Sometimes you need to understand it in as real time as you can. Sometimes near real time is okay. Sometimes once a week updates, that type of stuff. It just depends. For us, what we've seen. The first step, though, is just understanding your asset infrastructure, what it means and what you're trying to do with it. Once you can understand that, then other areas of the organization come along. And those decision makers become plentiful because they all have a stake in that asset and what it does, because assets affect everyone.
What's happened at General Motors is we had for a while the information technology group decided what projects were going to go forward just on their own. And that wasn't working for us very well in manufacturing because we're not cool. We're not doing the new products. We're keeping things running. So what has been done is we now have what's called a joint focus team where we combine a director of IT and a director of manufacturing together, and they will jointly look at the manufacturing projects. They have their own budget and allocation of capital, and they will assign the projects as they see fit best for manufacturing, and then that gets approved by our executive VP of manufacturing.
Good. There was a gentleman over here.
I have a question for Arun about the vibration sensor. The cybersecurity of that aspect, I know we've talked about it, but I would like to know what kind of protocol are you using, what tools you're utilizing, and what are the standards and practices that you are following for this vibration sensor and vibration switch?
Yeah, sure. So the security all the way from the device to the cloud. And so you have to talk about security from the perspective of the hardware itself, and then the transmission, and then there is security again from a cloud perspective. We'll talk in more, I'll keep it at a high level and can share a lot of, if you can follow up with me, there's a lot of information that we have. The hardware chip that we use was built by the iPhone hardware manager, a cool startup company in the Valley. It's quite advanced now. But so there's a lot of device security on just the device itself. And then, we use Wi-Fi. Today we are supporting consumer-grade Wi-Fi encryption and security. Very soon there'll be 802.1x enterprise kind Wi-Fi encryption, security. Wi-Fi is a battle-tested protocol. That's why we made a bet. And when you're trying to send vibration, we are sampling at like 20 kilohertz. It's like sending speech data. So we wanted a protocol that is both secure and can support high data rates, which is why we picked Wi-Fi. Once the data goes to the cloud, I mean, there's, cloud security takes over, usual things like HTTPS, TLS 1.2, how do you encrypt data? How do you make sure that, you secure data at rest in transit? So those are all things that we had to comply with. For example, we passed the NERC SIP requirements. In the nuclear industry, if you want to get this into a nuclear plant and get the data out, we had to pass that. So long and short is that, when you're doing both hardware and software with IoT devices, you have to think of security holistically, right from the device all the way to the cloud. And there are different standards in different parts of the architecture. But I'll be happy to share more details, offline.
And just one small follow-up. Are those devices rated for a classified area?
Yeah, it's class 1 Div 2, yeah.
Another question?
Yeah, it's class 1 Div 2, yeah.
I'm in a situation where we're early enough in this process, I don't even think I know what the size of the prize is yet. Everybody's talking about vibration analysis, but I'd like to know if a belt's breaking or something like that in the process. Have any of you had rich experience beyond vibration? In other words, do you understand, do you have a middleware SPC piece that tells you this many amps at this much load equals good, this much load plus X, something's wrong? I'm trying to get my arms around just how big that is.
Stefan, would you like to cover that one?
Yeah. So, I mean, in the end here, what you're talking about is calibration of the model, right? So how do we know what's good and what's not good? And I think, when you start out, my experience with that is you don't need any additional sensors. So I've been in this area for more than 15 years. And the very first real big project I did, in fact, for General Motors, they asked us, how many sensors do you want to put on there? In fact, the guy who was running manufacturing at the time asked, how many vibration sensors do you want to put on there? And it turned out that we didn't need any additional sensors because we were already so data rich and we didn't do anything with those data that we could actually make a big, big dent into the maintenance cost, but as utilizing the data we already had, classifying it appropriately, linking different data sources from Maximo to Prophecy, quality systems, and so forth. And we got a high enough correlation with anything we really wanted to monitor that would allow us to, make really a big dent on that in that first step anyway. So, so my advice is look at the data you already have, start there, see what it gives you, and then, advance in time. And if you wanna, so the only thing that's changing that game a little bit now is sort of the advent of machine learning and artificial intelligence, because you can now build these models much, much faster. They're already much, much quicker than they ever were before when you try to figure out what are the physics behind this. Now you can just, if you have a lot of data, you can try to glean of, what is good and what is bad based on those, machine learning algorithms.
Let me add just a little bit on this, and then I'll turn it back over to the panel. Our experience in terms of implementation is first use existing data. In the process industries, it's typically from a historian. In the discrete industries, it's other systems, maybe a quality management, something like that. Import that into a cloud application or whatever that has analytics. Most of these applications now have a variety of types of analytics that you can apply. So you can either do first order engineering type algorithms or artificial intelligence machine learning. The second thing then is after you've exhausted existing data, you have intelligent devices in your factory. PLCs have had Ethernet ports on them for a couple of decades that I know of. So you can start connecting to intelligent equipment on the plant floor and pulling the data out of that. And then the third step is to add I/O, and that should be your last step. And like some of the panel members have talked about, it's easy. Wiring can be extremely expensive, so using a wireless type of I/O gets rid of the wiring problem, and it makes it much less expensive to put the I/O in when you go to add the data. So number one is existing. Number two is intelligent devices, PLCs, robots, whatever you happen to have. And then the third is then adding I/O. That's kind of the last resort. If there's anything you guys like to add, please go ahead.
I was just going to say, as an example of one where we are doing just that, is on our conveyors. One of the key sensors that we use for the conveyor drives is amperage. And as that starts going up, you know that I've started to have a problem with the conveyor and I need to go do some maintenance on it.
So how do you read that?
They have a meter on it that sends it to the PLC.
So that's a meter you add?
Yeah.
Okay, all right. Good.
So just real quick.
Go ahead, yeah, please.
In 2013, we came here to do a presentation on IoT and examples for it. The implementation that we did was at City of Des Moines, and it was for the water reclamation facility. And the question I posed earlier is the same question we had then, is the same question I have now, is always ask why. Why are you doing what you're doing? There's data everywhere that exists. There's historical data. There's connective data through SCADA PLC. There's I/O data. There's just so much stuff. I always ask the question, why? In this example, they had pumps that were used for the process of water reclamation, and they were pulling down enough current to really cause some damage in their bills. So they were constantly looked at, so what can they do to operate those pieces of equipment more efficiently? So the why was right there. Reduce the amount of spend you have in energy. Great. How do I do that? That's when they had to bring in reliability engineering to understand how that thing consumes, when it's supposed to run, when it's not. And some of that data was available in historical sense. Some of it was available in the EAM application that they were using. Some of it was available through their SCADA systems and process logic control systems. Some of it was available in their OSI soft applications. Then they had to get all that data together. Then they had to make sense of it all. So just like you said, this variable is this variable is this variable is this. The sun is set at 10 o'clock during the day and the wind's blowing at 5 miles an hour. Some weird thing that happens causes this to happen. That's an anomaly. So we had to develop out that algorithm to find that. But over time, this data gets huge. And as he was mentioning earlier, you can offset a lot of that data to an environment that can have machine learning on it, to learn from that history, to put artificial intelligence, to be able to do a lot of other types of things. And that's where they are now. But the biggest question I always pose, and I'll do it one more time, is just why are you doing what you're doing? Once you understand why, understands the purpose of the asset, what it's supposed to do, and from there, you can be able to find out where these pockets of data are, and these active streams of data are, and being able to make an inference from them.
Good, good. All right. Another question? Did I see somebody's hand go up? We have exhausted the questions from the audience?
Do we have ice cream outside?
Oh, I know the real reason. Go ahead, all right.
I got a quick question. I'm Natalie McMillan with Intel. When you are talking internally to stakeholders within your company about the projects that you're going to do you find that any of them kind of rail against the word IoT? And are there other phrases maybe that you use to explain what you're doing to get buy-in quicker?
So I'm going to amplify the why here one more time. So I think of that as outcomes, but that's really what the why is, right? So I think if you start with the how, the technology, you're already in a space that you don't want to be in. You want to figure out, why are we doing this? What's the outcome we're after? What does success look like? And internally, that's how you want to start with that. Internal or externally, it doesn't really matter. Once you have figured that out, you can go after the how, and sometimes it's like use existing data. Raul said that. Sometimes it is, you have to change the process, how people work. all sorts of things, right? But starting with a solution and say, I want to do an IoT project, I personally think that's not the right approach. You know, a few years ago, you know, I think people would say, why don't you put RFID tags on here, right? That was another thing, you know. So why do you want to put RFID, right? I mean, it's define the outcome, and then everything else will take care of it. That would be my advice for that.
And just from our personal experience, it tends to be like this, it's our last resort. Not our last resort, but like we're there because the other things we've tried didn't work. It wasn't logical, it wasn't feasible with people, right? So we had to find a better solution, and this happened to be it. So it was definitely not like, hey, let's figure out where we can plug IoT into things so we sound hip. And so there wasn't a lot of pushback because this was a task people didn't want to do. And we couldn't manage it. So this was really additive, it was helpful, and then it was just about finding, like you guys said, how do you do it in a way that is reliable and secure and successful?
Good.
Yeah, at Stanford, I kind of have the reverse problem. Everyone's falling over themselves to try to get, you know, IoT going, and a lot of times there's, you know, wasted effort or duplicate effort, or what they're doing, the value of it wasn't really well thought out to begin with. But they always encourage innovation, and then what you can get out of it is all on the plus side.
Yeah, one thing we use is we don't even call it IoT. We say wireless predictive maintenance. Don't even use the term IoT. And it really goes back to some of the questions that were asked, right? You have to get to the fundamentals. You know, do you have existing data already to monitor the value of your machines? Then you can go with. You don't need new instrumentation. If you do not have what we've seen in a lot of industries like power plants and all that, the $1 million machines are very well instrumented, the turbines, but the problems are the weak links, right? One thing with machine learning I would advise is it's not the algorithms, it's the quality of the data. It's the fidelity of the data. You know, how fine-grained you're measuring, that's really, so you get to the fundamentals of what drives machine behavior. Do you already have signals for that? And that's, you get to the root cause, get to the fundamentals, and that will help you pitch this better. So I don't use the word IoT. I try to say predictive maintenance, wireless predictive maintenance. It describes it way better from a business perspective.
And I'll ditto that. We don't really talk about IoT. That's a technology that's used. It is, what is the outcome? What are we trying to get? If we can say that I'm going to a smart factory where the machines interoperate with us. I had an uncle who actually retired from GM. He was a skilled trades electrician, and he went to work at a new plant where all he had to do is walk up to the machine. You look at the screen, it says replace board XYZ. Okay, I'm done. No work for it. Well, for us, we want to get to that world where the machines know what's going on, tell us what's happening, and reduce cost, improve performance, reduce mean time to repair, mean cycles between failures increase. All of that are the things that people care about. And don't focus on what is the technology that's going to get us there.
Well, we're quickly approaching 3:30, so I need to end the Q&A session. Big hand to this fantastic panel.